All right, so today's lesson is on summation notation. Summation notation. And like the term says, it's a summation, so we're going to sum things. We're going to add some things together. The Greek letter, the notation we're going to use is the capital letter sigma. Greek letters were used in math and for different reasons. We already used some, we know, or that's pi. It helps us with area and circumference and volume of a circular shape or a sphere. Some other ones we used in math as theta, which is a variable usually used for angles, theta. And then we also use the lowercase sigma, kind of looks like that, to represent standard deviation in probability and statistics. So for this one, we're going to use the capital sigma, and it kind of looks like that. And it's used so we can easily note a series of terms that needs to be added together. Instead of having a whole page worth of formulas, we can summarize it in a short, easy to read notation. And so what it would look like is we have our capital sigma, and then below the sigma we have I, and that stands for index, but that's our starting point. I is our starting point. So that's for this first example, we're going to start at 1. So that on the bottom always is the starting point. And on top of the sigma, above it, we're going to have the ending point for I. And so in this case, let's make it kind of simple. Let's put a 4. So for this sigma, the summation notation, we're going to start at 1. Then we're going to end at 4. So to the right of the sigma is going to be our equation, our mathematical expression that we're going to use. And so in this case, let's do I plus 1. So that's the whole thing. That's what it's all going to look like. And if we were going to put all the terms after the sigma notation, the summation notation, we would start with 1 because that's where index starts. So our first term, let's put it in parentheses to kind of show each piece. So we're going to put in 1 for I. So 1 plus 1. 1's for I, and then we add 1 to it. And then we're going to put a plus because it's the summation notation. We're going to add it to the next term. So that's the first one. And then every time we have a next piece, we're going to add 1 to our index. Started at 1, so the next integer from 1 up is going to be 2. So we're going to say 2 input I plus 1. And then we're going to add another summation notation. We're going to add, we just did 1, then we had 2, so we're going to do 3 is the next one. We add 1 to our index each time. And then the next term, again, plus 4. So we add 1 each time because that's what our formula is. This part could say be anything here. In this case, it's just I plus 1. And so we did 1 because it was the index, started at 1, then 2, then 3, then 4. We don't put anything else. It ends the summation notation because our index says above it that ended at 4. Start at 1, end at 4. And this number is always, the above is always going to be larger than the one below it because it has to build up to that. It always goes upwards. All right, so then we have our 4 terms, and then we just do the math. 1 plus 1 is 2. 2 plus 1, 3, and 3 plus 1 is 4, and 4 plus 1 is 5. So 2 plus 3 is 5, plus 4 is 9, plus 5 is 14. So that would be the answer to this summation notation problem. Okay, so let's do another one. It doesn't have to be I. Normally, it's going to say I for that index, but it could be anything. So let's just make it a different letter. Let's say T, and let's start at 0. It doesn't have to start at 1. It could be anywhere. It could start at 0. It could be a negative number. It could start at 4, whatever number you'd like, and then we could end it also at some other integer. These are always going to be integers, -2, -1, 0, 1, 2, 3, so forth. And then the number above is going to also be an integer above, wherever you want to stop. All right, so then we'll need some formula here. And of course, since we have our index we're calling t here, our variable within the summation notation is also going to have to be t. So let's do this. T squared over 2t. Okay? All right, so we're going to expand that. We start with the first number for t would be 0, right? That's where our index starts, whatever. That's our first substitution in for t. So it's 0 squared, and then 2 times 0. So it can be in multiple places. Here, the very first one we just had one spot, but here now we have a t in the numerator and a t in the denominator, so we have to put it everywhere you see that t. So that's the first term, 0. And then again we add, if you want to keep it a little more organized, maybe put parentheses or brackets or whatever, make it separated, but we're going to have the 0 term, we're done. Then add 1. Okay, so then the next one would be t equals 1. So 1 squared, and then 2, because that 2 doesn't change, but the t now has become 1. So how I do it is, instead of doing a bunch of steps of math, the first step, just substitute in your index 0, and then 1, and then 2, and then 3, because we'll end at 3, and then set up your problem, and then the next step, start doing the math. Because it could be easy to get confused and make a mistake if you're trying to do multiple steps in one. Okay, so then plus, remember, we're going to have addition symbols always in there because this is the summation notation. And then we did 0, we did 1, and now we're going to do 2. So 2 squared, and then 2 times 2. And then the next one would be 3 squared, all over 2 times 3. And then 0 squared is 0, and 2 times 0 is 0. So that's all going to go to 0. Yeah, so 1 squared is 1, and 2 times 1 is 2. 2 squared is 4, 2 times 2 is 4 again. 3 squared is 9, 2 times 3 is 6. Okay, so that's our second step, but one set of math operations, and now we just combine them all. We're adding the terms together. So it looks like we only have some fractions. We're going to have to get a common denominator. So I think, let's see, let's go 1/2 here. And this is 1, right? So 4 divided by 4 is 1. And then we have 9 over 6. And it looks like our common denominator would be 6, right? So it's all going to be over 6. We'll combine all those three pieces here. So if the denominator is 6, we need to multiply the top and the bottom by 3 to get that 6. So 1 times 3, and then 1 in the form of the denominator 6 would be 6 over 6. So that's 6. That's our 1 term. And then we're going to add 9. So 3 plus 6 is 9, and another 9 is 18. All over 6, and 18 divided by 6 is 3. So that would be our answer. Okay, so that's pretty down and dirty description of summation notation. Again, the symbol we're going to use is capital sigma. All right, so for homework, it's going to be due on September 20th, 9/20. So homework, it's due 9/20. Let's do 3 problems. The first one be sigma I equal 1 to 5, and it's I squared. And our second one, sigma, and sometimes you'll see everybody does maybe a little bit different sigma, but that's how I do my sigmas. Kind of looks a little bit like a capital E, not exactly. And we're going to start at I equals 0 and go to 4. Let's extend that guy a bit. And our equation is going to be I plus 2 all over I squared. Make that a little bit better. And then the third one, we're going to have our sigma. Change up our variable a little bit. P equals -2 to 3. Remember, we can start at any integer, so it's going to start at -2. It's going to go up by 1 all the way to 3. And our expression that we're going to work is p squared minus p all over 4. Okay, so that's your assignment, and this was the summation notation lesson.